Believe it or not, this is week 6, another 2 weeks, and we'll be on spring break, and then it's all downhill from there. Chapter 9 gets us into more useful material that we'll be able to use when we get into really doing some scripting after spring break. So the first thing we talk about in 9 is modules. And modules are reusable functions. So some of the material, some of the scripts that we've created up until this point, several times we've recreated functions within those scripts. As an example, averaging. But we can create a reusable function that'll let us use that code once we have it perfected over and over and over again as many times as we want to. There are a couple of different ways that we can create these reusable modules. One is to create them as a Python file, a .py, just like we've been doing all along. That works very efficiently. However, there is a little cost in timing when you start to reuse that module over and over again. Another way to do it is to create it in a native language. C, C sharp, some derivative of that is another option for us, but that can provide some problems when we start to go cross-platform with the scripts and the libraries that we create. Modules can be imported into other programs. That's why it's important to make sure that you test your module, be absolutely positive it is doing what you want it to do, that it doesn't error out, and then you can use it in other programs. We can create what's known as a standard library of modules. That has to exist along the pathway of Python. And when we create this library, again, it can be usable with any Python script or program that we create. So modules and module libraries end up being very, very efficient tools for us, especially if you're a lazy coder, where you want to code it right, code it once, and then use it as many times as you can use it. One of the key events that we can do is something called import sys. Now that's a key word, and that is the built-in module within Python that can give us a plethora of information about what's going on not only with the computer, but also what's going on with our Python script. Our library can be put in anywhere along the sys path, and we took a look at that way back when we first started the class in week 1. Now, you're a little limited in the classroom environment because you can't go in and modify that system path, but where you can, anywhere within that path or anywhere you add to that path, you could set up your Python library. So it becomes a very, very easy library to set up once you get it built. Some miscellaneous notes out of Module 1 and 2. We're going to look at lists in more detail in Chapter 10, and we'll do that starting Thursday. The sys arg or argv, that contains a variety of different information. Take a look at section 9.1, and it'll give you a little more information on that. But basically, you're looking at the arguments that are contained within modules. Timing I mentioned before, and I want to cover a little bit more right now. Timing is a big concern if you use the byte compiled method. That's the .py file. You just create a typical Python file and use that as one of your library modules. The byte compiled or PYC module is compiled the first time it's used, but after that there's no compile time, so it imports faster. So we've got two different types of library files we can create. A .py file, which we are creating right now, and that's a normal file that we do when we generate a Python script, or a .pyc, which is a byte compiled file. Byte compiled files are platform independent, so they can go across a variety of different platforms. So you've got to weigh the conditions, the environment you're going to use this library in, and then decide what is the best way for you to proceed. Modules 3 and 4. Each module has a unique name when we start to talk about library modules. Nothing different than what we've seen in the first 8 chapters that we've done. My preference is to create a library file with some sort of unique identifier in the title of that file, so I can know that just by looking at the file name, that it's a library file. As we start to dissect these library modules a little bit further, we know each module has a unique name, and as I said, one of the things I like to do is put some kind of identifier in the file name so I know that it's a library module or a potential library module. Another interesting thing in the way Python operates is each statement in the module can identify where it comes from. And we'll see that as we get into building a couple sample modules here in just a couple of minutes. Not only that, the modules and the calls that we make using the library can identify specifically what scripts are running. So it can tell you whether the actual Python program that you're running is controlling what's going on, or if a library script is controlling what's going on. We create them like any other Python file, any other module that we're going to create. Here in the classroom, we're going to use the .py extension. They need to be placed in the same directory as the scripts or programs that you're going to be run. So I would recommend you create a project and then keep all of your library functions. So again, Classroom is kind of a not a wild environment. It's very controlled. So I recommend that you create a project, drop your library files into that project, and then add in the program or the script that you're going to run with it. The other option is to take a look at that system path and figure out a directory that you can put it in. The last time I checked as a student logging in, you couldn't even access to look at the details on the student path. So I think the option of putting it in the same directory with your scripts is going to be the best way to proceed. This is the first sample module that we're going to do this morning. And this could be the beginning of your library if you desire. But if you would, go ahead and type this into your Python project that you have open. Make sure, if you would, that you add line 3 if you don't have that in your header information. And we're going to use that a little bit later in the lecture. So I'll give you a couple of minutes to get that started. Let's talk about lines 6, 7, and 8 for a second. Lines 6 and 7 are pretty unique, are not unique to what we've been doing in the first 8 chapters. What do you see about line 8 that's kind of unique? We're putting a version number in. And notice we're designating that variable a little bit differently. By the way, what type of variable is it? Okay, I'll give you a hint. Is it numeric, character string, or animal? Character string. All right, good, good. Fortunately, nobody said animal. Okay. Now we've got to develop a script that's going to use this library, our first library function that we created. So what I'd like you to do is go ahead and create this module. Now I want to point something out to you at line 10. Notice when we type in my module and we put a dot there, a period to bring to enter what we're going to use, notice what comes up. The underscore version and the underscore date, even though that underscore date isn't declared under the definition as part of the activity of the module. So we'll talk about that a little bit later, but go ahead and enter this in. Let's look at the script that we wrote that's going to call our module, and most particularly take a look at line 6. That's what is importing the my module that we created before that has our version number in it. So we've got to do that first before we can access that library module. Then take a look at line 9. Line 9, we have the my module dot say hi. If we back up, notice say hi is the name of the definition. So we're Bill Gates again. So we're pulling in say hi with the module name. Very, very simple, very similar to a lot of the 4GL languages that are out there. And then line 10, where we have the print version number, we're actually pulling from my module the version that we created. And it works fine when we take a look at the printout. Hi, this is the module speaking, and it's version number 0.1. By the way, do you know why you would use a version number .1, .2, .99? Anybody have a guess?
So that you don't get up to millions real quick?
Kind of, but normally a 0 dot number indicates that that version has not been released yet for use. So as you develop code, the code we developed out at FAA, everything was 0 dot. And it's a very easy way when you're in an establishment that uses a lot of code and is continually evaluating code. As long as you use a 0 dot, you know that that's not code that's been tested and is ready for release or ready for trial in an airplane or at UPS or whatever. Just a little background for you. Let's go ahead and change the module and add in line 11. Print my module dot underbar date underbar. Add in whatever text you want to add in for that. Did everybody get that? And so when you run it, now we're actually picking up the date of the library module that we created and printing it out also. Kind of a nifty little way to do it if you need to check the dates of the library modules that you're using, assuming you've got the date coded in there. We can go through and we can also add an author. Now what you would have to do is add the author module or the author line to the my module, And then you could do the same thing. You don't have to do it, I did. And here's the printout that we get. So hopefully you see that as you set up your library modules, you can determine what you're going to print out or additional information that you might want to use for testing the program that you're writing or working with the script that you're writing to give you some insight into how your code's operating. So it works extremely well. Let's look at modules 5 and 6 real quick, and then I've got a little challenge for you for the rest of class. In module 5, we talk about the keyword dir. And dir lists the identifiers of any object that we're using within Python. So it can talk to us about functions, it can talk to us about classes, and it can talk to us about variables that we're using. They give you an example in section 5, but that needs to be coupled with other code to use, and that's going to come a little bit later. For now, just be comfortable with the fact that dir can give us more information about the functions, classes, and variables that we create. And I think the week before we go on spring break, we actually get into classes, and that'll help clear up some of the things that we're doing. Of course, variables and functions we've already looked at. Module 6 has got a little more information in it, and at least our author at this point starts to suggest the way he likes to design Python scripts and programs. First of all, his desire is that variables go inside functions, functions go inside modules, and global variables are usually included inside a module. So that's kind of a good way to get started. Again, develop your own style. If you go to work for someone that has a specific way that they want you to create programs and code in the information, they'll let you know. In fact, for Thursday, I'll bring you a sample of how we coded things out at FAA to give you the style that we wanted to use. Normally, packages are folders of modules, and we can create those with an init.py file. And module 6, 9.6, gives you an example of that. It gives you the sample of code, but it really doesn't tell us how we're going to implement it. And that actually comes a bit later. So now what you want to take a look at is just the fact that we can create folders of modules. Now, we'll get into this more when we get into standard libraries next week. My challenge for you for the rest of class is to create another module for your library that adds up 4 numbers. And there'll be 4 numbers that you send to it. And then call that from the script that we wrote to use our first library. So your script, when you're successfully completed, we'll call that first library, tell us that library is in control and its version number, and then add up 4 numbers that you sent to your second library module. Question?
Just help with the previous thing.
Okay. Anything else? All right. When you think you have a solution, let me know.